morning, everybody. Welcome to our maths camp. While you're here, we're going to use trigonometry to calculate distances, areas, and angles. We will hopefully have a little bit of fun while we do it. You're all going to be working in teams. We're going to extend your knowledge of trigonometry in this series so that you can use trig for any kind of triangle. So why don't you make notes as you follow along? By the end of this lesson, you should be able to use trigonometry ratios to calculate the sizes of angles in a right-angled triangle. You should also be able to solve a problem in a triangle by dividing it into two right-angled triangles. To start, let's look at the trig that you've already learned. So far you have learned about sides and angles of triangles and found some important relationships between them. Let's quickly go over some of these important things. Let's look at triangle ABC with a right angle at C. By convention, we can label the sides like this. The side opposite angle C will label C. The side opposite angle A will call A. And the side opposite angle B will call B. Now, can any of you remember what the trig functions are?
I remember the words sine, cos, and tan, but I'm not sure what to do with them.
That's okay. Sine, cos, and tan are the ratios of the sides of a triangle. We can use them to help us calculate the values of sides and angles of a triangle that are not given to us. We define these ratios in relation to a specific angle in the triangle. Let's use angle A in this triangle. We can define the sine function of A, the cosine function of A, and the tangent function of A. We need to label the three sides in relation to the angle that we're interested in. The three sides of a right-angled triangle can be defined as the hypotenuse, the opposite side, and the adjacent side. The hypotenuse is easy. It is always the side opposite the right angle. It's also always the longest side of the triangle.
Okay, so C is the hypotenuse.
Good. Now, which side do you think is opposite angle A?
It's that one there, little a.
That's it. The side opposite the angle A. The other side left over is the adjacent side. Adjacent means next to, and you can see that side B is next to the angle A. Now, can you tell from the diagram what the sine of angle A is as the ratio of the sides of triangle ABC?
I'd like to have a go at this. Sine A is the opposite side divided by the hypotenuse.
Why don't you come and show us?
So that's A divided by C.
So what about the cosine of A?
So that's adjacent divided by hypotenuse. So that should be B divided by C. I know the other trig ratio as well.
Go ahead.
It's tan A, which is opposite divided by adjacent, which is then equal to A divided by B. Thank you, sir.
Good, good. Okay, why don't you all split into groups?
Hey, how'd you remember all of that?
That was pretty easy. I just used SOHCAHTOA.
What's that?
Come, I'll show you. I write down SOHCAHTOA like this. This is short for sine is opposite divided by hypotenuse. Cos is adjacent divided by hypotenuse. And tan is opposite divided by adjacent.
I think I'll write that down.
These trig ratios are really important, and you will use them all the time in trig, so why don't you make a note of them? Now here's a challenge for today. Each team has been given a pack. In this pack you will find a compass to help you with direction, a map, a calculator, a pen and paper, and a ruler. Now have a look at the map first. If you would like to do these activities with us, you can find a copy of the map on Mindset's website, www.mindset.co.za, or in the lesson notes for this series, or you can copy it down now. Okay, your task is to find your way to the heart using the shortest route.
How do we do that?
Okay, why don't you take a look at the map first, give it a bit of thought, and then I'll give you the answer.
Okay, so this is where we are now.
And here's the hut. That doesn't look too difficult.
Yeah, but we don't know which direction to take. Do we go this way or do we go that way? I mean, we can see that this distance is the shortest on the map, but what direction is it in?
Have you tried using some of the maps we did earlier? You have all the other information you need right in front of you. And don't worry, if you go too far off course, you can always contact me on your walkie-talkies and I'll come and help you.
Let's see what else is on the map.
Here's Buffalo Hill, and it's directly north of where we are now. Hey, this is easy. We work out where north is using the compass. Then we just walk north for 22,6 kilometers to Buffalo Hill. And then follow the road for 12 kilometers till we get to the hut.
That means we walk for... let's see, 34,6 kilometers. There's got to be a better way.
And we still don't know what direction to take.
You're on the right track, but now think about this. This is a trick question, so we need a
Triangle?
Oh, I get it. If we join our 3 points on the map like this, we get a triangle, and then maybe we will see things more clearly. Okay, now I can see it. We want to find angle A. We have the hypotenuse of 23,6, and the adjacent side here is 22,6. So we can use cos. Cos A will be adjacent divided by hypotenuse. That's 22,6 divided by 23,6. So to find A, I take the inverse function of cos. By my calculations, angle A is 16,7 degrees. I reckon we can round that off to 17 degrees.
Are you sure about those angles? I mean, look here. We know the angle at H here is 71 degrees, so A and H should add up to 90 degrees, right?
Right.
So A will be 19 degrees.
I'm confused. Where did we go wrong? I used trig, and you used the sum of angles of a triangle. Maybe these are just estimates. Don't you think we're close enough?
I reckon we take 18 degrees. That's halfway between 17 and 19.
Maybe we should get some sort of maths tip.
Oh, all right.
Okay, how are you guys keeping up?
We're just a bit stuck.
Well, the problem is that you both assume that it is a right angle triangle. Remember that trig ratios only work on right angle triangles. So how could we check if it is a right angle triangle? Okay, if it is a right angle triangle, then we can use the Pythagoras theorem on the sides. In a right angle triangle, the square on the hypotenuse will be equal to the sum of the squares on the other two sides. For this triangle, that means 22,6 squared plus 12 squared is 654,76. And 23,6 squared is 556,96. So AB squared plus BH squared doesn't give us the same answer as AH squared. So this triangle is not right angled. And if this is not a right angle triangle, it means that we don't know the sides at angle B. So we cannot use trig ratios here. We need to find another way to calculate the angle at A.
But we've only ever used trig in a right angle triangle. Is there something else we need to know?
What do you think? Is there another way to make use of the trigonometry to find angle A? Let me give you a hint. Can you find a way to create two right angled triangles out of triangle ABH?
How about drawing a line through here, from B to AH?
I think we must make sure that line is perpendicular to AH.
Good thinking. Now let's make a sketch of what we have. Here's triangle ABH. I can draw the perpendicular in here and label this point D. This is only a sketch, so I don't need to construct this accurately. Now we have two right angle triangles. So let's see if that helps us find angle A.
Well, the trig ratios could help us with each of these triangles. In triangle ABD, we want angle A, but we only know the length of AB, So that's not good enough information.
Yes, but look at triangle BDH. We have an angle H of 71 degrees and a side BH of 12 kilometers.
Right. So we can use that to find the length of BD. Then, when we found BD, we should be able to find angle A from that. Brilliant!
So in triangle BDH, we can use angle H. I put my finger on H, so BD is the opposite side and BH is the hypotenuse. The trig ratio for opposite divided by hypotenuse is sine. So sine 71 is BD divided by 12. I get BD will be sine 71 times 12. On the calculator, I get 11,35.
Let me take it from here. We know that in triangle ABD, BD is 11,35 and AB is 22,6. We want angle A, so I'll put my finger on that angle. AB is the hypotenuse because it is opposite the 90-degree angle, and BD is the opposite side, so I can use sine A. Sine A is opposite divided by hypotenuse, so that's 11,35 divided by 22,6.
I'll do the calculator work. 11,35 divided by 22,6. Then to get A, I need the inverse of sine A, and that's 30,1 degrees. I guess 30 degrees is close enough.
30 degrees? That's a totally different angle from our 18 degrees. We would have gone in the wrong direction. Thanks for helping us with the trig.
Anytime. That's what I'm here for. By the way, let me know if you need help with the compass. Finding your bearings with the compass can take a bit of practice. As you go, it might be a good idea to stop every now and then and check that you're still heading in the right direction.
Gee, thanks.
Let's go over what we have achieved today. We have learned a few important lessons through today's challenge. First, drawing a diagram is a good way to see the problem more clearly. Second, trig ratios only work for right-angled triangles, so don't assume that all triangles are right-angled. And lastly, when triangles are not right-angled, they can sometimes be broken up into right-angled triangles. Now for your task. If I have an isosceles triangle ABC, with AB and BC as equal sides of 10 meters each, and I know the angle between them is 100 degrees, what is the length of AC?
Do you think we're still on track?
I think so. I think we've walked more than 10 kilometers. So we should be...